Hi everyone, my name is Larnell Rogers, a marketing manager at Samsung Electro-Mechanics. We recently released a video on TCC, and today we'll discuss aging. This is our third educational video with more to come. So let's start today with a question. How does time affect the capacitance of an MLCC? If you're new to working with MLCCs, you may not know that aging has an effect on an MLCC's capacitance. And today, we'll learn more about why and how that happens. Aging is a natural phenomena of MLCC materials, as capacitance decreases over time. The reduction rate of MLCC capacitance due to aging differs depending on the characteristic of materials, and in the case of C0G, there is almost no change. Aging is reversible. After heat treatment of 125 degrees or higher, the original capacitance can be restored. In order to understand the principle of aging, it's necessary to understand the BaTiO3 lattice structure. BaTiO3, or barium titanate, is the primary material in the MLCC dielectric layer. Barium titanate has a characteristic such that the lattice structure changes according to temperature. Above the Curie temperature, each atom is arranged at equal intervals to form a cubic structure with no polarity. When the temperature drops below Curie, the structure changes to tetragonal, and the central Ti4+ atom moves up, resulting in polarity. After an MLCC is sintered at 1000 degrees Celsius or higher, it will maintain a paraelectric cube lattice structure down to a temperature of 125 degrees Celsius. The barium titanate dielectric is enlarged within the grain boundary. It can exist in the same cubic form without polarity, under the cubic structure. However, when cooled to below 125 degrees Celsius, the lattice structure changes to tetragonal, and polarization is formed as the Ti4+ atoms rise upward. At this time, polarizations in the same direction are grouped together, which is called a domain, and a domain wall is formed between domains moving in different directions. In this state, the dipole degrees of freedom are at maximum and the capacitance increases rapidly. However, as the cubic structure changes to tetragonal, the lattice is stretched up and down, causing physical stress, and as a result, some dipoles are rearranged left and right. In this case, the rotation probability of the dipoles decreases due to the AC field, which is constrained in the domain structure, and ultimately, the capacitance is reduced. This reaction is reversible if heat treatment is performed at a temperature of 125 degrees Celsius or higher. The lattice returns to a cubic structure without polarity, and capacitance is recovered.